Hi, everybody. I'm happy to see that you made it through the introduction and that you decided to dive right into this course. So I'm happy to talk to you about our first feature, which is trend prediction. Now, trend prediction, what's that about? Well, remember in the introduction, I talked about proactive monitoring, where you want to predict the behavior of your network. And then when you see an issue, you want to report it. Well, that's where you use this trend prediction to look into the future. So I hope you're ready because we're going to predict the future together. Now, let me start by showing you what it looks like in DataMiner. So I'm going to show you a real life demo in the next video. For now, let's just look at this snippet. When you open up the trend graph of a parameter, this is the kind of thing that you typically see. You see here the historical behavior of the parameter. Then you have this now line, and then you see a prediction. That's the trend prediction algorithm in action. All right. Now, before showing you the real life demo, I would like to discuss just a few technicalities. First of all, I want you to know that we don't create just one prediction, but we actually create 4 predictions. And depending on the amount of zooming that you do on your trend graph, a different prediction is shown. Now, what kind of predictions do we create? Well, when you fetch trend data, you actually fetch trend data on various aggregation levels. First of all, DataMiner keeps real-time data. It typically stores that for 1 day, but you can change that in the settings. Next, DataMiner also stores 5-minute average data. This is typically stored for about a month. Next, we also store hourly average data, which is stored for about a year actually. And finally, we also store daily averages. Now, for each of these 4 data sets, we create a different prediction. For real-time data, we create what we call a high precision prediction. For 5-minute averages, we create a short-term prediction, and then we have a midterm and a long-term. Now, how many data points do we need to create a prediction? Well, we typically use between 300 and 2,500 points. If you have less than 300 points, on a certain aggregation level, then we will not create a prediction on that level. So how much history do you need? At least 300 points. Another typical question I get is, okay, how far along in the future can you predict? Well, this depends on the amount of points that is available. If you only have 300 data points available, then the model is less good than when you use 2,000 points to create a model, because there are more dependencies and patterns that you can find. So as a rule of thumb, we always predict 10% of the number of data points into the future. So if you're using 300 data points, we only predict about 30 points into the future. But if you have plenty of trend data and we can use 2,000 data points, well, then we can predict 200 points into the future. Now, this 200 is really a hard limit because whenever you have a model and you predict a point and another point and another point, the uncertainty keeps on growing. So you don't want to go further than 200 points. Then the prediction becomes just too uncertain. We don't want to do that. What does this mean concretely? Well, concretely, it means that for real-time data, say a polling time of 10 seconds, we can predict 200 times 10, so 2,000 points into the future. That's not a lot, but the prediction does have a lot of detail because we predict 1 point for every 10-second interval. So the prediction is very precise, which is why we call this the high precision prediction. If you're looking at the 5-minute average data, then we can predict up to 200 times 5 minutes, which is 16.6 hours into the future. For hourly data, we can predict 8.3 days into the future. And using daily data, we can predict 200 days into the future. Of course, the flip side is that you only predict 1 point per day. Okay. Now, I already mentioned that sometimes you will not see all of these 4 predictions on your screen. The reason can be that there's not enough data available, but there's another reason. Sometimes the data simply does not have an underlying predictable structure. For example, think about the case that you want to predict the first lottery number of next week. Okay, say that you input the first lottery number of the past 5,000 weeks. So you have 5,000 points to train your model. Well, you're still not able to predict that lottery number of next week, simply because this data is completely random. There is no underlying predictable structure. If we detect that your data does not have an underlying predictable structure, we will not show a prediction. Okay, well, I hope that's clear. That covers all the technical things. So I'm very happy now to jump into a demo.